before I start doing this, anybody who has gotten this? They have gotten this question. Is it a question that you guys think you can solve very, very easily without my intervention? Or is it something you would want me to do? Is it a question you would want me to do? Or is it something that Mwalimu should not even bother because you're so good at it? It's tricky, eh? Let's do it. Let's do it. So remember, here we are told you are provided with the following information on put and call options on a stock. So they have given us call price, the call price. We have the put price. Thank you so much. We have the exercise price given there. We have days to option expiration. We have current stock price. We have number of days in a year. Then we have what we call risk-free rate, which is 5%. So in this case, they want us to use put call parity. The parity means that are equal to calculate the prices of the following: synthetic call option, synthetic put option, synthetic bond option. When they brought this question in this semester, so many people got a 0, 0, 0, 0, 0, 0, like that. And yet this is really a very easy question, because what we need to do is to write the parity equation. You write what we call the parity equation. Parity equation. So parity equation, I hope everybody is able to remember this. We normally say, in this case here, call option minus put option will always be equal to the stock value, in this case here, minus the present value of the exercise price given. So remember, CO is the call price, PO is the put price. Then we have SO, which is the stock price. And then we have PVX, which will be the present value of the exercise price. Please let me know once you're able to write up to here. And of course, O means what here today. Like when I say call price, it means today's price. O means today, present, today. All right, I can see they want us to move pretty fast, but have they finished writing up to here? Have they finished writing up to here? All right. So then what we're going to do, ladies and gentlemen, anytime they want us to really get these synthetic values, what we need to do is to rearrange, in this case here, forms of synthetic assets which are needed. So rearrange the above to give, rearrange, always. You shall rearrange the above to ascertain values of required synthetic assets. So like now, number one, they want us to give them the synthetic call option. They want us to give them the synthetic call option. So the synthetic call option basically makes CO the subject of the formula. Make CO the subject. Make CO the subject of the formula. Could you kindly do that for me? Make CO the subject. From this parity equation, you simply, because they want call option, you make CO the subject of the equation. You make CO the subject of the equation. Do we know how to make these figures here subjects of the equation? Do we know how to make these figures, how to make these things subjects of the equation, subjects of the formula? It's very, very easy. So in this particular case, if they want to make CO the subject here, so CO here will be equal to SO minus PV of X, plus, because this is going to the other side, So plus PO. The very first thing that I would want you to do for me if you get this kind of a question in an exam, please go ahead and give me PV of the exercise prize. So have they given me the exercise prize? Oh yes, exercise prize has been given. It is there. It is on the third row there. Exercise prize is 30. And it is a lump sum, so I have to discount this by multiplying this by PVIF. PVIF. So then this one here will be 30. Is there anybody who is able to remember the formula for getting PVIF? Because it's a lump sum, so this cannot be PVIF. It's a lump sum. It's a lump sum. So it will be 30 into, is there somebody who is able to remember the formula of PVIF? Let me see. You know, as the pressure increases, people forget very basic things. People forget very, very basic things. You can see now nobody's talking. Yeah. So in this case here, 1 plus R raised to negative n. So then this one here will be 30 into 1 plus R. The R in this case here will be the risk-free rate. The R in this case here will be the risk-free rate. Are you able to see the risk-free rate in this question? Are they able to see the risk-free rate in this question? 5%. So 0.05, and so many students mess up here. Remember, N has to be, because this 5%, of course, is an annual thing. So N has to be number of years. In most cases, in this kind of questions, they'll give you number of days. So I want this to be number of years. So is there somebody who is able to give us the number of years? Very easy. Number of years. I can see the number of days to expiration. Number of days to expiration. Number of days to option is 219. Divided by how many days in a year? Divided by 365 days in a year. So is there somebody who can give us this? Yeah, so then raised to 0.6. So is there somebody who can give me this PV of the exercise prize? PV of the exercise prize. Everybody must ensure that they are able to raise. You say 30 times into brackets, 1 plus 0.05 close, and then you say raised to. The raised to, you'll be able to see the raised to like that. So in this case here, they are telling me that you have 0.6 years like that to expiration. Yes. Remember, you could also, in this case here, take this as E raised to negative RT. E in this case here was a very old way of discounting. It will give you approximately the same answers. Approximately the same answers. So what are we able to get, my good students here? We are able to get 29 point what here, somebody? 29.13. Let me know whether all of us are comfortable with this figure. Let me know whether all of us are comfortable with this figure. So that is present value of the exercise price, which will be applicable all through, So then let's get back here, ladies and gentlemen. We are saying that this is what we call the parity equation. This equation, you must cram it. You must cram this equation. It is CO minus PO equals SO minus present value of the exercise what here? Present value of the exercise price. You must cram that. And then now we go to the requirement. The requirement, the synthetic asset value that they want us to get, first of all, there in Roman 1 is the synthetic call option, the CO. And what have we said about this CO? Make CO the subject of the formula. So how do you make? So number 1, synthetic call. Synthetic call. So synthetic call, make CO subject of the formula, which will be equal to SO minus present value of this exercise. This is crossing over. Now it becomes PO. So do we have these values from our question? Is there somebody who is able to see SO? SO is the current stock price. SO, somebody who is able to see SO? SO, 33.19, isn't it? 33.19. Are you able to see the present value of the X? We have just computed it. 29.13. This is the put price. The PO, it's given in the question. The PO is given in the question. Second line there. We have here 2.79. 2.75 actually. 2.75. So then that is it. you are able to give us what we call the synthetic call. Synthetic call. Synthetic call. Synthetic call. So what are we able to get there, ladies and gentlemen? So according to Margaret, we have 6.81. You have your correct answer. So many guys are not able to answer this. Then if you great students of mine are following, I would want somebody to go ahead and give me the synthetic put. Synthetic put. Number 2, synthetic put. I'll give you 2 minutes. Try giving me the synthetic put. I'll give you 2 minutes. Give me the synthetic put. So present value for X, somebody got 27.59. I think so you are the only one, Elizabeth. Were you able to raise? You know, it's all about just raising. You say 1.05, then you raise this one to negative what here? 0.6. You raise this one to negative 0.6. Just know how to raise. And then whatever answer you get, you multiply it with 30. This answer seems to be correct. This answer seems to be correct. So synthetic, whenever you want to get a synthetic asset, you must always go back to the call-put parity equation. You must go back to this. And then now you make which one the subject? You make PO the subject of the formula. Is there somebody who was able to make this PO the subject of the formula now? You make PO the subject of the formula. Not many, I cannot see many answers. I can't see many answers. I can't see many answers. I can't see many answers there. So go ahead and make PO the subject of the formula. So if I make PO the subject of the formula, then what do they really want me to do here? So I'm making PO the subject of the formula. All right. So in this case here, synthetic put. So make PO the subject from this. You must cram this, write it many times. So make PO the subject. So then what I will do, ladies and gentlemen, I will take this PO to the other side. I will take PO to the other side. When it crosses over, it becomes positive. And then I leave this one here, so CO. But now all the others here must cross over, right? So minus SO plus PV of X like that. Plus. Because you see, alternatively, I can take this to the other side. But now remember, this will be negative. So you must change the signs. All right. So then what is our CO that has been given there? The call option value. Not the one that you got up there. No. Here, remember, you must use the actuals. The ones given in the question. The ones given the question. This is the only one that can become synthetic. So our CO, the one given in the question, the actual one, not the synthetic one, the CO, I can see it is 6.64. 6.64. Minus SO, the one given in the question. SO, the one given in the question, is 33.19. Present value over X is 29.13. So is there somebody who is able to give us this answer now? So I'm being told by Lavi, I'm being told by Beauty, 2.58. Is that okay? 2.58, 2.58, 2.58, 2.58. That is the answer. Thank you so much. 2.58, that is the answer. Thank you so much. I don't know whether making PO was a problem. Was making PO the subject a problem to some of us? Was it a problem to some of us, making PO the subject? Making PO the subject. There are so many ways of doing it. Can I rub this? Have you guys been able to write up to here? Have you guys been able to write up to here? All right. So then I can rub this comfortably. You see, if you want to make this PO, then the subject, if it has an issue for you, then what some people will do, they will take this CO the other side. So they'll say minus PO equals SO minus PV X, and then our CO is crossing over. So upon crossing over here, it's positive. When it crosses over, it becomes what here? Minus. But you see now, I don't want a minus PO. I only want positive PO. So then all the terms here, we have to change their signs, all the terms. Yeah, you divide by minus 1. So then this one here will be minus SO. This will be plus PV X. And then this one here will be plus what here? CO. Yeah. So then if you try, even if you leave them this way, you'll still get the same answer because you see our SO. Our SO is given here. Our SO is given here. Our SO is given here as 3.19. Plus present value of our exercise price, which is 29.13. Plus our CO. Our CO in this case here given here is 6.64. So are you able to give us this synthetic PO? Will it be the same? Will it be the same? Will it be the same? Yeah. So really it's upon you to know how to place these things in the left side of the formula. Like if I'm the one doing this, I will consider, because this PO is negative, I'll consider taking it here and then I bring the others the other side. But you see how to make the subject of the formula, that really is your business. Yeah, the negatives can also cancel out. Like, but how now? Is it only negatives? You see, when you cancel this, then this has to change, becomes negative, this becomes positive, this becomes positive. So, but are we okay, Goretti? Are we okay up to there? You know, it's about really, now this is about you, isn't it? Maybe you have a better way, but it's about you really. I think we have done my work, isn't it? For 1 and 2, I've done my work. And then now for part 3, they want us to give them the synthetic bond. The synthetic bond, remember now you will be required to exercise and make a payment later. So the payment you'll be making later is a debt to you. So whenever they tell you, ladies and gentlemen, to give us the synthetic bond, you basically make PVX the subject of the formula. So for synthetic bond, make PVX the subject of the formula. For synthetic bond, the last one now, for synthetic bond, make PVX the subject of the formula. So Roman 3, synthetic bond, yeah, make PVX the subject of the formula, please. So please try that. Please try that. And for the students who never came to this class on time, you'll be forced to watch this video from the beginning, probably tomorrow. Yeah, it will make sense if you watch from the beginning. Otherwise, you may not be able to really appreciate the content over here so much. So make PV the subject of the formula. Do we have a ninja who has been able? Remember, you're going back to the parity equation. You're going back to the parity equation. Let me see how they'll be able to make PV the subject of the formula. Repeat? No. Do we have time for repeat, Oye Mungai? No. We will just give you the video, Mungai, isn't it? We'll give you the video. Once we give you the video, and then actually videos at times are very good because you are able to fast track them, isn't it? You can say ×2. You watch at ×2. I know students of RCM, they're very good at watching this video. Somebody told me ×3, but ×3 is not practical. ×2. ×2. Okay, so let's try in this case here, making PVX the subject. So you can take this to the other side. So if I take this to the other side, it will be PVX. It will be PVX positive, because I've pulled it to this other side. And then this remains SO. And then I pull this to the other side. Here, this becomes negative CO. This becomes plus what here, somebody? Plus PO, like that. So do we have this actual? Remember here you're using actual values that are given in the question. So SO figure the stock price. You know SO is the stock price, 33.19. Minus the call price. The call price is 6.64. Plus the put price. Put price is what here, somebody? 2.75. 2.75. So what figures are you able to get, ladies and gentlemen? Here I'm being given a figure of 29.3. 29.3. So is there somebody who has been able to appreciate how to do this question in a way that if it came, they'll get all the marks? Any student who has been able to appreciate how Mwalimu has done this question, if it comes. But the most important thing, you must be able to remember the parity equation and don't write Mwakenya. Don't write Mwakenya. If you forget the parity equation, how it looks like, then automatically you will not be able to get what here. You will not be able to get here. There is somebody who told me something to do with the couple. Couple, I don't know what they meant, but couple. So you don't confuse this S or couple. Start with couple. Yeah, couple. And maybe soup, I don't know, but at least couple. Couple. And then both of the sides here, we are subtracting. Please don't let me down should they bring this kind of a question. All right. SO is stock price. The stock price, the one that is provided. The stock price, the one that is provided there, stock price. Remember, CO is call price. PO is put price. X is the stock price. That student who is asking that great question, Miriam, I would invite you to watch the video. Don't fail to watch the video, please. Don't fail to watch the video. Is that okay? Nisonge kidogo. All right. All right. So is that okay? There are students who are overthinking. There is somebody there who is asking me whether which Roman 4 can be brought. Don't overthink. These are enough. You can imagine even if they had the Roman 4 and then you answer the 3 correctly. I'm telling you, you are a genius because these are those kind of questions nobody will answer. You are a genius. Okay? Sawa, sawa. Is that okay, ladies and gentlemen? I can see you have so many questions regarding this, but now remember, I'm the driver. Allow me to move on, isn't it? Allow me to move on because today's session, I'm trying to look at her. I mean, even when I sleep around, I look at her. What are those kind of areas? If the examiner twists my students, he can easily get them. Yeah, he can easily, very, very easily get my students. If this guy brings this concept of binomial. If he brings this concept of binomial, there will be very, very few students who will be able to get binomial right. How I pray my students will be able to get all the marks under binomial correctly. So are you ready? I invite you to a question of binomial tree. We attempt it together, or are you those kind of students who are every time fearing these things? We do other simpler things. So do they want Mwalimu to do a binomial tree? A binomial tree still under derivatives? Great. Thank you so much. Ready. And that question, ladies and gentlemen, came in April 2023, question number 2B. It was a crazy question, but very easy for me because fortunately I did an MSc in finance, and the MSc in finance, derivatives is one subject, the whole of this. A whole subject just covering derivatives. Yeah, that's how I got to understand these things. April 2023, question number 2, boy. Are we there? When do I become a professor? It's quite tough to become a professor because number one, I'm not teaching in a university. So I'm not supervising any PhD students. Yeah, not unless you give me a very, very good, I don't know what can make me now to start teaching in a university. Remember Lincoln, I was teaching JQuat 12 years ago. I've taught at Daystar. I think I've done enough there. I've done enough. And most of these universities don't even pay their lecturers. That time, I would rather invest that time at RCM. I would rather invest that time at RCM, so I may not become a professor. All right. JQuat Juja, I was there. Did I teach you, Samuel? We make RCM a university. Wow. Great. Thank you so much. Thank you so much. Thank you so much. Thank you so much. All right. So then now we have gotten this question. Consider April 2023, question number 2B. April 2023, question number 2B. Question number 2B, April 2023, question number 2B. I have to open up my lens a little bit because I want to draw a tree. I'm so sure this will disadvantage some students, but I don't think I have an option. So we are told to consider a two-period binomial model in which a share price currently trades at 65. The share price can go up 20% or down 17% each period. The risk-free rate is 5%. So they want us to give them the price of a put option expiring in 2 periods with an exercise price of 60. This is a very, very easy question. So what we shall do, first of all, is to calculate the upward factor. Upward factor, the U. So this U, remember U, in this case here, they have told us that there are two possibilities. That this option could either go up by 20% or it goes down by 17%. So the upward factor up. So in this case, it is 1 plus 0.2, which will be 1.2. And then we have in this case here, downward factor, yeah, D. So in this case here, we can see a situation where our price is going down by a whole 17%. So then our D will be equal to what here, somebody? Yeah, M in this case here wants me to go to St. Paul University, but why would I go there? If RCM, for example, has 4,000 students, even if each student was to pay 10,000, that's about 40 million. And then, of course, we have our staff. Why would I go to a university? Do you know what rate they pay over there? We shall overcome. I'm better off 100, actually 100 million times here. Here, let's make RCM a university. Let's make RCM a university. So downward factor D, 1 minus 0.17, which gives us 0. What here? 0.83, which gives us 0.83. So up to there, ladies and gentlemen, are we together first of all? Up to here, are we together? Yeah, thank you so much. So that is the first thing that you need to do. That is step number 1. Get the upward factor and the downward factor. From there, ladies and gentlemen, draw a probability tree. Draw a probe tree, which basically is a binomial. Binomial. Remember binomial, your examiner at times will use the word binary. When you were in Form 2, most of us were being called by something, isn't it? By means 2, 2, 2, 2. All right? So in this case, ladies and gentlemen, we shall draw something like that. So this is year 1. Year 1. So year 1, remember we are starting this exercise from 65. Yes, we are starting this from 65. And then there are two possibilities. At the end of year 1, it will either go up or down. So if it goes up by 1.2, what will be the new price? Somebody here. Because there are binomial, two occurrences. So if it goes up by 1.2, the new price will be 65 times 1. Have you seen where I got 65 from? Have you seen where I got 65 from? Yeah, it is given in the question. We are told in this case here, current means today, it is trading at 65. So somebody is giving me a figure of 78. And then we have in this case here, should it go down, it will be 65 times 0.83. Can somebody give me this figure? 53.95, right? 53.95. Thank you so much. Thank you so much. So that is the end of year 1. Remember, they have told us to use what here? Somebody 2 periods. 2 periods, to use 2 periods. So this is period 1. Then now we go to period number 2. We go to period number 2. We go to period number 2. Period number 2. So period number 2, how does this behave like? So period number 2, there are 2 possibilities. If the price was 78, when we go to year 2, we could either again have this thing going up or down. So if it goes up, I multiply by 1.2. If it goes down, I multiply this by 0.83. So is there somebody who is able to give me this figure? So 78 times 1.2, what figure am I able to get? If it goes up, if it was 78, there are 2 possibilities going to year 2. It could either go up or down. So 78 times 1.2 gives me what figure? 93.6. I'm being given a figure of 93.6. Yeah. What if it goes down? Remember the up and down, those are constants, eh? If it goes down, it will be 78 times 0.83, which gives me 64 point what here? 64.74. How about this one? If this one was the end of year 1 parameter, when it goes to year number 2, when it goes to year number 2, there are two possibilities. It could either go up, so up movement, you multiply by 1.2, and if you're right, we expect when I take this times this, it should be able to agree with this figure. And if it goes down, we multiply this figure by 0.83. 0.83. So is there somebody who is able to see that this figure is agreeing? The middle figure must always agree, eh? If it doesn't agree, you're not doing the right thing. You're doing it wrongly. So 53.95 times 1.2, this gives me that. 53.95 times 0.83 will give me 44 point what here. So ladies and gentlemen, even if you are to stop doing this question at this juncture, you can't get a 0 because at least you have understood the concept of binomial theorem. Binomial theorem. So up to here, is there somebody who has been able to pick this concept very, very well? Yeah, great, great, great. So then, ladies and gentlemen, after you have been able to do that very well, please look at your question. The next thing will be for us to get what we call payoffs. The next thing will be for us to get what we call payoffs. Yeah, how do we get these payoffs here for a put? Remember, this is a put, for a put. So for a put, you will take maximum over 0, yeah, 0 minus 0, 0, comma, 0, comma, yeah, k or x minus s here, minus s. So for each node, you are going to give us our payoffs for our put option. And how do we get these payoffs for each node? It's very, very easy to get payoffs, ladies and gentlemen. You're going to have your nodes, and these nodes are 4. There are 4 nodes. So we have node 1, node 2, node 3, node 4. There are branches as well. There are branches as well. There are branches as well. All right. Now, ladies and gentlemen, we want to go to each branch. Yeah, each branch. All right. And then we calculate this. Yeah, we calculate this. I don't know whether that space will be enough. We start with branch 1. So remember, we are picking the maximum. Maximum between what here? 0. In this question, ladies and gentlemen, have they given us the exercise price? Have they given us the exercise price? Abracadabra. Is there somebody in the requirement? Is there anybody who is able to see the exercise price? 60. So you take 60 minus the current spot price. You know, this is stock, current stock. So current stock as per node 1. The current stock is 93.6. So can somebody give me this difference? Somebody give me this difference. So this will be 60 minus 93.6, which gives me what figure? Which gives me what figure? It will be minus something, isn't it? Oh, now they are not talking to me. How I wish we never started doing a bad question. It is minus that. It's a very good question. You love it. It's a very, very good question. It's a very, very good question like that. So 0 and minus the 3.6. I gave you an example sometime back here of this option of this hotelier in Nairobi who is going, in this case here, to have an arrangement with a farmer in Kirinyaga County. I don't know whether you use Mbere, but Kirinyaga County will be good because they plant lots of potatoes there. So then you agree, ladies and gentlemen, with this person at Kirinyaga County to plant like 20 acres of potatoes. And then during harvesting, 6 months from today, you'll be able to go and do what here? Buy potatoes from him at 2,000 bob per sack. Now remember, it's an option. So then when I go down there, 6 months are over, before I go to my contracted farmer, I must pass around and see what other people are selling their potatoes at. If I get somebody who is selling their potatoes at 1,000, Will I go back to my farmer to buy those potatoes as 2,000? No. Remember, in options, you can never make a loss. In options, there is no obligation. You have the right, but you don't have any obligation. So if I see I'm going to lose, I would rather not exercise. I would rather not exercise and get zero. So like now here, I'm faced with two options. Either I get zero or I get minus 33.6. So that's why we said you choose the maximum. So in this case here, what will be the payoff? How I wish this board of mine was very, very big. So in this case here, I can come and create here a column and talk of payoff. So in this case here, the payoff I will get will be zero. Because I'll be in node 1, I'm seeing there is a zero and there is a loss. There is no way in options you will ever make a loss because there is the option of you bolting out, saying I won't exercise. So in this case here, I will make a zero there. Can we go to number 2 and then you give me a payoff? Let's go to number 2 and then you give me a payoff, somebody. S in the formula, thank you very much. So this S is the stock price for year 2. For year 2, remember now year 1 is like, it's none of my business. So year 2, the existing stock price here is 93 point what year? 0.6 now. And the excise price will be constant for all of them. Excise price will be constant for all of them. So in this case, Evans is giving me -4. You can't make losses with options. So in this particular case, I'll be able to choose what here for option number 2. Is there somebody who is saying 0 here, and then you give me the last one here? Because you see here, if I consider this concept of maximum, what am I doing for option 2? I know 0 is constant for comparison to avoid me making a loss. So I'll talk of 0, exercise is 60 minus this 64 point. And as Evans is telling us, this one here gives me a negative. So in that case, I'm going to choose 0 for my payoff. I would rather not get anything than making a loss. That is the concept of options. That is the concept of options. How about this one? When you come to this one, option number, or rather this 0, and then of course 60 minus the same, 64.7. Still here, I'm making a loss. I will choose 0. When I come to this one, I'm choosing between 0 and a 60 exercise minus 44.78, which somebody has been able to tell me, Mwalimu, here now we have a positive. If I'm going to profit, I would rather go for the profit than 0. So in this case here, they have been able to give me 15 point what here, somebody? 15.22. Ladies and gentlemen, trust you me. By the time you are getting those payoffs, you've scooped almost all the marks. You've scooped almost all the marks. What I would want to know, I know maybe my speed could be a little bit higher, but are you able to follow somehow? Are you able to follow somehow? Somehow. Of course, I'll be able to provide the video later on for you to follow, because these last minute questions at times you'll get them in the exam. You'll get them in the exam. The last minute questions are very, very important. Very, very important. They're able to follow somehow. Now, from there, what do? You'll be able to give us, ladies and gentlemen, a probability tree of payoffs only. So step number 4, I think this is step number 4. Probability tree of payoffs only. The same one, but now payoffs only. Payoffs only. Payoffs only. Payoffs only. So we have year 1. Yeah. Then from year 1, we have year 2. Yeah. Only payoffs. Payoffs only. Payoffs only. Payoffs only. So payoffs 0, 0, 0, and then we have 15.22. 15.22. Only payoffs. I need still to expand this a little bit for my we shall overcome. Yeah, that's much better. Payoffs only. Payoffs only. Don't bring any other thing there. Payoffs only. Now, ladies and gentlemen, after you do that, then you'll be able to get to almost our last step called probability calculations. You give us what we call the risk-neutral probability. Risk-neutral probability. So after you finish doing this, come and give us the risk-neutral probability. Risk-neutral probability. How do I get this risk-neutral probability, my very, very good students? To get this risk-neutral probability, what I'll call P, let me just get a very good place to write this. What I will call P, risk-neutral probability, it is normally very, very easy. What you need to do to get this probability of risk-neutral, you will take 1 plus R. You subtract D. All over U minus D. Is there somebody who is able to remember the U and the D? Yes, if you can work without probability, but without the trees, the better as well. If you can work without them, the better. But I think schematic presentation of a work simplifies things. We are taking the maximum, but you see now negative ratio. Those two have got the 2, the 15 or something was negative. So you compare 0 and minus 15.02. Which one will be higher? 0 will be higher. The higher between 0 and the negative. 0 will be higher. So then, ladies and gentlemen, this risk-neutral probability, it will be 1 plus. Are you able to remember this risk-free rate of return? It's given in the question. Risk-free rate of return, it's given in the question. Oh yeah, I'm alone, but I will overcome. I'm alone, but I will overcome. 5%, isn't it? So 0.05. Are you able to remember the downstroke? Downstroke was 0.83, isn't it? Downstroke was 0.83. Downstroke was 0.83. And the up was 1.2 minus this down, 0.83. So this probability, risk-neutral probability, will be 1.05 minus 0.83. All over 1.2 minus 0.83. So then at the end of the day, who is able to give me this answer? I'm being given an answer of 0.59. I'm being given an answer of 0.59. I'm being given an answer of 0.59. Is that okay? All of us, are we able to get, you work kando. You get this numerator divided by the denominator. So we are getting this risk-neutral probability is the probability here, 0.59, meaning that this other one here will be 0. What? Why they're not following? Because it's binomial. It's binomial. 0.41, isn't it? Yeah. So the same you apply here. 0.59, 0.41. 0.59, 0.41 like that. Because once you get this 0.59 risk-neutral probability, so automatically then this will be 0.59. The other one will be complementary. 0.59, the upper one, like that. So you have your payoffs. So what you need to come and do is to give us the joint probabilities. Come and give us the joint probabilities. Give us here the JPs. Joint probabilities. So joint probability, you take like now for branch 1, you know it is 0.59 times 0.59. Times 0.59 because you follow through. Is there somebody who can give me these 2 decimal places again? Joint probability. 2 decimal places. 0.35, right? 0.35. Now look at this branch number 2. Branch number 2, you Subaru driver. This is our road. So this will be 0.59 times 0.41, which will end up giving me what figure? How did you get answers? Which answer? 0.24, eh? Yeah, please come to this other branch number 3 now. So branch number 3, third branch. So you're following it. So this will be 0.41 times 0.59, which will end up giving us what figure, ladies and gentlemen? Which will end up giving us what figure? They're telling me it is 0.24, eh? 0.24, and then we have here 0.41 times 0.41. So 0.41 times 0.41 Is there somebody who is able to give me this figure? I'm being told it's 0.17. And of course, if you are very right, except rounding off errors, we expect these probabilities here to add to 1. The joint probability, except rounding off errors, which may be there because we are taking this to a lower figure, we expect to get 1. It is 1, isn't it? It is 1. So because of lack of space, you will allow Mwalimu to come and call these ones. You see, these are payoffs, and these are JPs, joint probabilities. I'll write them here: 0.35, 0.24, 0.24, 0.17. So just like how you do it in advanced management accounting, you will take now the payoffs times JPs, times probabilities. So in this case here, create a column here where you take the payoffs times probabilities. So 0 times this is 0, 0 times this is 0, 0 times this is 0, 15, 22 times, no. This is 0.15, eh? 0.17. I think I confused here. Yeah, there's nothing there. So it is 0.17 times 15.22. What are we supposed to be getting somebody here? 2.59. 2.59. So then what is the expected future value of option? You add everything. 2.59. 2.59. You add everything. We are lucky here because most of the others were what here? Zeros. So expected future value of the option, it will be 2.59. But you see, you want present value using binomial tree, using binary tree. We want, in this case here, present value of the option. So what do you think shall I do with this figure to make it present value? We need to discount it. So go ahead and discount it. Yeah, with the risk-free rate. So the last step, you discount this at the risk-free rate. So go ahead and discount. So discount. So to get the present value, take this 2.59 times the sum of figure PVIF. And you are the gentlemen and ladies who gave me the PVIF formula as 1 plus R raised to negative n. This is 2.59 times 1 plus 0.05 raised to negative 2. Because it is 2 period. It is 2 period. He has never brought 3 period. If he brought 3 period binary tree, I'm so sure people will cry. But at least my students now, they have some way of doing this. They'll be able to figure out some way of doing this. So are you able to get that 2.35? 2.35, and that is the final answer. And the students who said they have another method of doing it, I'm 100% sure they got that figure. This may appear a bit longer, but you see why I like it. You are able to follow easily. It may be your very first time to see it, but I believe, ladies and gentlemen, that you have been able to get some insights which could be helpful to you, especially when you get to watch the video later. Yes. On getting the joint probabilities. Florence, Norma. Norma, is there somebody who has been able to pick something out of this? Anybody who has been able to pick something out of this? Because that one of just raised, multiplying by 1.2, I don't think it is really that difficult. At times we create big mountains out of a small, very little hills. Got lost on how we got the joint probabilities. Understood 110%. Yeah, 110%. I'm telling you, if you sit down and repeat, I'm so sure like we have done this in our revision kits. We have used that formula of saying P plus plus for 2. This is schematic. And if you practice like myself, if you give me this question, I do it with this approach, I'll be able to finish even within 6-7 minutes. Quicker. Here I moved a bit slow simply because I'm teaching. So please take your time later. I don't think I'll be able to repeat like now how we got the joint probabilities, etc. I'm so sure you'll be able to get this video and watch later. Can we agree about that? Or you want again Mwalimu to repeat this question here like 100%? Can we agree about that? So there are two formulas there. There are two formulas which should be able to give us approximately the same figure, but please adopt this formula for getting this risk neutral probability. Just adopt this. Adopt this to avoid many, many issues. Any formula you use there will be okay, but just adopt this. You'll watch tomorrow, right? So we continue. Now, ladies and gentlemen, but I think this you must have done it in class. I don't want to waste your time with whatever you've done in class. I'm just trying to think. We have taught this AFM very well, but what can throw some of our students underneath the bus written CASNEB for students who are going to pass, and then they throw you outside the bus. We don't want you to be thrown out. So should they bring anything to do with options, they can easily bring this question here. August 2024, question number 5B. August 2024, question number 5B. August 2024, question number 5B. If you have done it in class, please, I would rather we do other things. I have so much to do for you today. August 2024, question number 5B. Question number 5B. Have we done this in class? Have we done this question in class? We use the you. Oh, we haven't done it. So this basically is about an option to delay. Option to delay. Yeah, we have option to delay. We have option in this case here to expand. We have options to contract. We have options to abandon. Yeah, so this is a very, very good one. It doesn't matter whichever they bring. So long as you've got some knowledge of this, you will easily end up getting all the marks. You'll easily end up getting all the marks. All right. So then with your permission, I will be able to do this very, very easily. Very, very easily. I can see CN is complaining there. Don't complain. Don't complain. You will pass. That one I'm always guaranteed. Remember, we have quite a high number of students, like AFM, if you look at evening and early morning, whatever, about 700. And trust you me, those 700 students will pass. That one I can guarantee you. This time round, you'll be very, very lucky because should they bring this by Black-Scholes model, they'll give you tables. You shall be given tables. You shall be given the normal tables. Normal tables. 𝐭𝐨𝐻 Limited, a property development company, has gained planning permission for the development of a housing complex at Moore Greens Estate, which will be developed over a 3-year period. The resulting property sales, less building costs, have an expected net present value of 4 million, with a cost of capital of 10%. Cost of capital of 10% per annum. They never gave that here because we expected you guys to have those great calculators. But I was in some meeting where people said, I mean, why do you push everybody to buy a calculator? Yeah, so don't worry. So we are told there, the cost of capital is 10%. 𝐭𝐨𝐻 Limited has an option to acquire. Read that. 𝐭𝐨𝐻 Limited has an option to acquire land in Moore Greens Estate at an agreed price of 24 million, which must be exercised within the next 2 years. Immediate building of the housing complex would be risky as the project has a volatility attaching to its net present value of 25%. Volatility is the standard deviation. All right. One source of risk is the potential for development of Moa Green Estate as a regional commercial center for the large number of farms leaving the capital. Because of high rents and local business taxes, within the next 2 years, an announcement by the government will be made about the development of transport links into Moa Green's estate from the outlying areas, including the area where 𝐬𝐭𝐚𝐫𝐬 holds the land option. The risk-free rate is 5%. So they want us to estimate the value of the option to delay the start of the project for 2 years using the Black-Scholes option pricing model. So this is very, very easy. So if it's option pricing model, then number one, you give us D1. Remember those basic steps, Give us D1. Give us D1. Is there somebody who is able to remember the formula of getting D1? Are they able to remember those formulas of the Black model? The Black's model. The Black model. Black's model. Black's model. How do we get D1? Oh, yeah. It is Napierian logarithm, P over E, right? Plus, we have the risk-free rate into a half of the variance multiplied by T, standard deviation, root T. So you start by giving us D1. This examiner was a very nice examiner. He gave you the formula. If you get a very bad examiner, a pessimistic examiner, a sadist of an examiner, they cannot give you the formula. So remember this P, ladies and gentlemen, will be equal to what here, somebody? P. Is there somebody who is able to give us the value of P? At least I can see Goretti there is able to remember very well. So abracadabra, these guys are not talking to me. These guys are not talking to me. P is the spot, but in this case here, we are dealing with a gigantic project. We are dealing with you can't see a price. There's no price there. There's no price of a share. No price of a share. There is no price of a share. So remember that this P is supposed to be present value. Present value of the investment. Present value of the investment. Present value of the investment. And you can see, ladies and gentlemen, this examiner gave us net present value. And anytime they want us to give them net present value, we normally take the present value minus initial outlay. Present value minus initial outlay. So NPV has been given as 4 million. Present value is what we want. Do we have the initial outlay here in this question? It's given there that it has an option to acquire land in Moa Green's estate at an agreed price of what year? At an agreed price of 24 million. At an agreed price of 24 million, like that. Meaning, ladies and gentlemen, that our PV will be, take this to the other side. It will be 4 million plus 24 million, which gives us 28 million. PV will be 28 million. And then remember, E is the exercise price. Exercise price. So exercise price is the amount I have to pay to acquire this project. So in this case, are you able to see the exercise price? This is not an abandoning question. This is an acquisition question. It's a building question. So in this case here, the exercise price is 24 million, like that. So then can you kindly go ahead and give me this D1? However, when we are marking these exams, even students who use NPV here will still give them all the marks. If you get a student using NPV here, we still give all the marks because not many students are able to remember that really this has to be present value. By the way, we are very liberal. Whenever it comes to marking, we are very, very liberal. If you get yourself failing in AFM, chances are you never answered any question. Yeah, because if you go to AFM, ensure that first of all, you get like all the theory marks. And then one great computational question is taken down correctly. Trust you me, you'll never see me again at this level. You'll be able to go where? Up. So anytime you get yourself failing, don't blame us so much. Yeah, it is you as a student who at times, in this case here, messes up. Because even, for example, when you're supposed to be starting reading, most of us have not been reading. Now we have gotten like 2 or 3 days over the weekend to read. Now you'll get another ninja waking up tomorrow at 11. And then they'll start, in this case, saying that, you know what, I've now slept enough. Now in the afternoon, I will start reading. During lunch hour, they get to ugali moto, sukuma wiki, and avocado. So they say, I'll start reading from evening. When evening comes, let me start tomorrow at 4 a.m. I put an alarm. When that alarm, in this case here, goes up, again, I snooze it. And then, of course, you'll get yourself like this Monday, let me just go and escort others. The 2 days can really make a can make a very big difference, the 2 days. Because now you have what we call our learning management system. In our learning management system, for example, once it has reached weekend, don't be cheated by people that there is a leakage or whatever. You go to, if it is AFM topic number 1, plus whatever you've been able to do over block release. Those things that you are now very good at, brush over them. Go through them. Like every topic, you only watch like 2 videos, 2 questions. CASNEB questions done there, 2. Go to topic number 2, like that. And then ensure that you answer the theory questions. You will never see me again at this level. But if you procrastinate, take yourself, in this case, on Monday to go and escort others. It shall be well. It shall be well. It shall be well. It shall be well. And that is why some of us, we are also here to ensure that we escort you to the exam. Super tired. I can imagine. I can imagine. I can imagine. On my third, Anna, I'm not teaching people who are going for this thing one term. So we shall overcome. Now we have everything. Let's go ahead and do what here? Let's go ahead and do what here? Get this D1. So then our D1 will be equal to the Napierian logarithm into P. So this is 28 over 24. Of course, million will cancel. You can put it there, million. Plus, have they given me the risk-free rate of return? Have they given me the risk-free rate of return over here? 5%, right? So 0.05 plus 0.5 times, what is the standard deviation given in the question? Remember, volatility is not variance. Volatility is standard deviation. So what is the standard deviation given in the question? The standard deviation, 0.25, right? 0.25, 25%, isn't it? So 0.25 squared. Remember that T has to be in years. If they tell you the time is 6 months, time to expiration, is 6 months, take 6 months divided by 12. But here we are very lucky because we are given time as 2 years. We are given time as 2 years like that. And then now everything, you come and divide this by 0.25 times root of time again, which is 2. So then first of all, let's get what we have in the numerator. So what we have in the numerator, we shall use any calculator. You say ln. I hope you are able to see where ln is. On your calculator there, I hope you can see where ln is. So you say ln, that ln has to come up. And then you open bracket, 28 million divided by 24 million, you close bracket. You relax a little bit. It's not a jail area. I'm not time pressured in AFM. Plus, open brackets, 0.05 plus 0.5 times 0.25 squared, close brackets times 2. Give me the one answer for the numerator. Is there somebody who is able to give me one answer for the numerator here? Just one answer for the numerator. Remember, it's not the normal logarithm. It is the Napierian logarithm. On your calculator there, they are calling it in. On your calculator there, they are calling it in. Lincoln is giving me 31 31,665. 665. I can write many decimal places, yes. Are you able to see? Are you able to see where we have in? It's written in. It's just near there. You'll be able to see near the red thing. Near the red thing where there are logarithms, you'll be able to see the in thing. All right? And then you pick, in this case here, that ln. Don't forget to put this in brackets. So then you say 28 million divided by 24 million, you close. Then you say plus, open brackets, 0.05 plus 0.5 times 0.25 squared, you close, times 2. Don't say equals anywhere in between. You can only say equals at the end of the day. So you're getting that 0.31665. How about the denominator? Are you able to give me the denominator value? 0.25 times root 2. 0.25 times root 2. What are we able to get there? 0.35355. 0.35355, which then will end up giving us what figure of D1? Which will end up giving us what figure of D1? 0.88, 0.88, 0.88, 9, 0.88, 0.8956, 8956. Thank you so much. 8956, 8957, same thing, isn't it? Same thing. Now, once I get that, straight away, then I'll be able to get my D2. So my D2 is like this. My D2 is like this. So D2 will be D1 minus root of, yes, standard deviation root of T. This diagonal. You take D1 minus this. So you take D2 will be equal to D1 that you have just gotten here, 0.8956 minus this, the way it is, 0.25 root 2. So is there somebody who is able to give me this D2 figure? Anybody who is able to give me this D2 figure? Anybody who is able to give me this D2 figure? I'm alone, but I will overcome. The Black's model is called Black's model. It's called Black's model. It's called Black's model. So then our D2, oh, I've rubbed mine. I'm really sorry. You're really going fast. But you see, I'm moving with the speed of the students who are giving me answers. You do want me to repeat like from the beginning? How many students would want us to repeat from the beginning? Because I've rubbed. Do you want us to repeat from the beginning? Yeah, so you can see now everybody is saying in this case here, if you can't cope up, yeah, you watch on the LMS, but I will be careful. I'll be careful. But again, ladies and gentlemen, you are saying I'm moving fast. I thought these are things you are done in the normal class. Or we shall overcome. Or we shall overcome. We are done, but Mwalimu, we shall overcome, right? Because I even thought like, ladies and gentlemen, if you are done them in class, you could even be just watching without writing, isn't it? Just watch and then, because it is the same thing. Same thing. So then we have our D1 figure and we have our D2 figure. Yeah. So please remind Mwalimu, what is our D1 figure? Yeah, next is normalization, isn't it? So D1 figure is 0.8956, 8956, and then D2 is 0. D2, you guys have gotten D2, 0.5421, 5421. So please now come and change this to 2 decimal places. 2 decimal places. 2 decimal places for us to be able to read this from our tables. So 2 decimal places, this will be 0.90, right? 0.90, 2 decimal places, this will be 0.54. So from there we go to normalization. Normalization. So normalization, now you give us what we call ND1. ND1, and then you give us ND2. Yeah, so ND1 will be 0.5 plus N3. Entry of D1. This will be 0.5 plus N3 of D2. If you're using a calculator, it's quite fast. If you're using a calculator, it's quite fast. So 0.5 plus entry of D1. Why am I saying plus? Because the figures are positive. If any figure was negative, assuming D1 was negative, then I would have said 0.5 minus entry of D1. Our figures here are positive. Our figures are positive. All right. Yeah, you'll be given tables this time around. If you want to be given tables, we shall complain. They'll be able to give you free marks. We shall complain, and then they give you free marks. So tomorrow, what time do we meet for AFM? Are we still meeting tomorrow, or do you want this to be it? Are we still meeting tomorrow, or do you want this to be it? That this is our last meal? Academically, no. Yeah, I want to escort you to the exam. I want to be with you throughout. I know why. Mm-hmm. All right. So then I'm trying to get my normal table. Normal table. And the normal table that I have here is very interesting. I love this. So it's on the QA paper. Get used to it. And if you have a calculator and you know how to use it, the better, the very, very best. But you see, that means buying some other type of a calculator, which will cost you currently at about 3,000 shillings. 3,000 shillings. Yeah, like there is this normal table, you can see it here. Yeah, one tail, standard normal curve. Yeah, so we start with D1. D1, ladies and gentlemen, is 0.90. So 0.90 is here. Yeah, so you can see the entry is 0.3159. So this will be 0.5, 0.5 plus 0.31 plus 0.31, yeah, 0.9. You know, D1 is the same as Z, Z score, 0.90, 0.3159. And then, ladies and gentlemen, you can see ND2, it is 0.5 plus entry of D2, and the D2 is 0.54. So are you able to see 0.5 is here? 4.54. Somewhere here, 2054. This one here, 2054. So plus 0.2054, plus 0.2054, like that. Why are we adding this 0.5? Why are we adding this 0.5? It's because of the ugali ya Mluya. Ukumbuke ile ugali ya Mluya, you know, it is only Luyas who can do very good ugali. All these other tribes, we are not very good at balancing ugali. So you see, when I talk of D1, for example, when D1 is 0.90 here, D1. So you see, the entry is this. But you see, for us, we want like the whole thing from the beginning. And here we have 0.5 now plus this entry there. So then this gives me 0.81, 8159. This gives me 0.7054, like that. So the ninjas who used their calculators, were they able to get the same answers? The ninjas who used their calculators, were they able to get these figures? 0.8159, 0.7054 on the table. You cannot carry. You cannot carry. Or they're saying 7051, okay, maybe these guys are wrong, it could be 51, whichever. We can't use our 1 plus R. You see, Goretti, there is a difference between a normal table and a present value table, Goretti. There's a difference. Whatever you're telling me there is a present valuation. Present valuation. And these are normal table. Normal table, you could either use a calculator or a normal table. Or a normal table. How to read? So how to read this? Then there is also cumulative table. So cumulative table, you don't add. So you can see this is a partially shaded table here. Yeah. So like, for example, it is 0.90 here, 0.9. So you see this Z is always one decimal. If you want the second decimal, you read from here. So 0.90, this one here. Yeah, 0.3159. If you want 0.54, 0.54 is here, 2054. You come to 0.5, the second digit is the fourth one here. So 0.2054 like that. Now, my good students, then having gotten that, are you able to tell me the next step? The next step in this case is for you to come and give us value of a call option. Give us value of a call option. How do we get value of a call option? I'll always remember that subject that I liked most in primary school, for sure. Somebody may think that I really loved mathematics. No. In high school, what I loved most is physical education, PE. And then here you come and do ND1. Yeah, minus E, ND2. And then remember, this excess price must always be discounted. So to discount this, you divide this by E raised to RT, the one that you had this gentleman called Lincoln mentioning. Remember, these are Black's formula. We use ERT. We use ERT. So to get value of a call option, this is the formula. To get value of a call option, this is the formula. Yeah, so then the first thing you'll do is to come and give us E raised to RT. So give us here E raised to RT. So then this will be E raised to our R. Do you remember our R? Our R is a risk-free rate. Is there somebody who is able to remind us what this R is? What a show off. What a show off. That's somebody saying there. We shall overcome. We shall overcome. Is even hanging, okay? 0.05 times TT is 2 years. So then this will be E raised to what here? Somebody, please. What is 0.05 times 2? We don't want to guess things. We are now tired. What is 0.05 raised to times 2, I mean? Is it 0.1? 0.1. So are you able to do this in your calculator? Try to see where E is in the LN. In the LN, if you see up there, you'll be able to see E raised to X. So say shift E raised to X. Once that E comes up, don't raise again. It's already raised. So you simply go ahead and put E 0.1. You'll be able to get the answer there. Don't raise again. Don't raise. It's already raised. So I'm getting 110.52. I'm getting 110.52 like that. 1.1052. 1.1052. So the moment you see that in thing, it's called Napierian logarithm or natural logarithm. Once you see it on top, you'll be able to see E raised to X. And because it is yellow color, then you have to say shift that Napierian logarithm. So you're getting that. So then can you kindly go ahead and give me this value of the call option? Now we have everything. Are you able to remember our P present value? Was it 28 million? Times ND1. ND1 is here, 0.8159. Minus the exercise price was 20 million. Times ND2, 0.7054. But now remember, this exercise price is being discounted using this. So you divide this by 1.1052 like that. Then at the end of the day, ladies and gentlemen, what figure? E. Somebody should be able to assist Ching. I like what Evans is saying. I'll struggle to get, I don't have to get all the marks. And that is really RCM for you. What we want is you to go and do what here? Pass. Yeah. And that is why even when you are watching videos, once you realize that you have reached a level where you can't understand anything at this level, leave that thing. Go to something else. Widen your scope. That's how you learn. That's how you learn. Yeah, like for example, myself, I had a very good mathematics teacher in high school. I mean, they used to tell us that this thing is not about accuracy. And that's why some of us, we really loved mathematics. It's not about accuracy. It's about going to a question and trying, first of all, to comprehend it. And then once you comprehend it, exercise, do a few questions here and there, like that. You'll be able to get your A plane without even knowing that you even deserved it. You'll be able to pass this paper without knowing that you deserved it. Yeah, it's about imperfection. But of course, with efforts. With efforts. So then what figure are we able to get at the end of the day as value of the call option? Capital E of 20 million tumetoa wapi? 20 million is the exercise price. Is the exercise price. If you look at your question very well in that particular paper, the question very well, they've given you exercise. Is it supposed to be where did I get 20 million from? Look at me. Where did I get 20 million from? Or is that what we call imperfection? Is that what we call imperfection? Is it supposed to be 20 or 24? Sorry for that. And thanks for really bringing this up. Even if we want to be imperfect, I mean, no. Some things are quite obvious there. Thank you so much. So 7.53 million is the value of the call option. And therefore, total value of the project, total value of project will be NPV given plus this VC. So it will be NPV up there is 4 million plus this 7.53 million, which will end up giving us something there. Munga is saying, Mwalimu, you're also tired. Yes, since morning, it's not easy. Right now, my demand is crazy. I try to run away from QA students, from MA students. They kept me come here. Here now I have AFM. We shall overcome, but I love what I'm doing. And this figure is positive, and therefore, the project and the option. The project is viable, the option is viable. The figures are what here? Both of them are positive. And even the overall figure is what here? But at times you get the project being viable and the option being negative here. Yeah, we don't want anything that takes down our NPV. So in this case here, overall, the project and the project with the option is viable. The project with the option is viable because the option is increasing the value of the project. So that is what you are required. How do you remember all those contents shall overcome? Faro umetulenga this time round, woe hatari kabisa. Yes, you see now, ladies and gentlemen, if in this case here you are told, you see this is a call to delay. Yeah, it's an option to delay. So an option to delay is a call option. Very, very important to delay because you'll be able to buy later. That's a call option. Then we have an option to expand. If you're told in this case here, get this supermarket, later on you'll be expanding, you'll be buying. That's a call option. But if you're told in this case here that there is an option to abandon. You know, when you're abandoning, you are selling your unfinished project at a throwaway price. So even if it's at a throwaway price, an option to abandon is a put option. So if they told us that this option in question was to abandon, then automatically I would have gone a step further and calculated the value of the put. So is there somebody who is able to remind us the formula for getting value of the put? But I think that will be chasing perfectionism. I think even if it's a put option and then you derive it up to here, if I were you, that will be more than enough. You'll get so many marks. But just in the case for that student who wants an award, is there somebody who knows how to get value of a put? So value of a put will be value of what here? Somebody, the call. And then you take this to the other side, minus, in this case here, the P, yeah, plus exercise price divided by E raised to RT. Remember, for put option, you don't incorporate probabilities, because you're the one selling. So these things are certain to you. These things are certain to you. So if it's a put option, we normally take this VC, you take this, the other side, it becomes a minus, but now without ND1. This one on the other side becomes a plus without ND2. And then you'll be able to get the value of a put option. Once you get this value, then you'll be able to add it to the NPV to get value of the project with an option. Total value. Total value, somebody should be able to share that with Ross. Ross is very disappointed, but we shall overcome. We shall overcome. We shall overcome. All right, ladies and gentlemen, I think if we stopped here, it will be perfectly fine. I've killed so many birds in the air, right? I'm so sure if they bring a derivatives, especially option, it's the only thing option I haven't done is the currency option, which I will start with tomorrow. Just in case they try to toy around with my students will be perfectly fine. Yeah. And then, ladies and gentlemen, there is something you need to be knowing. Whether you're going to do your own business, like some of us, run a college like ours, or for example, run an audit firm like I run an audit firm, I don't think in this case here, most of these accounting students are giving it their all in terms of this profession. I don't talk politics, but if there is anything good that our president has done to accountants is to try to tighten things at KRA. I'm telling you, because of that tightening, most of us, like now, we have become like lawyers. Every time I'm at the tribunal representing what your clients, because now they are getting letters. Right now, as a business, you can't survive without an accountant. So the profile of the accountant will be raised, not today immediately, but the next 1 year, if the same automation continues at KRA, where people will even be tracked with them on their mobile phones and whatever, please be ready. How do you get to be ready? Ensure that you get a low-level entry job, learn. Most of the people, like currently, I have about 12 interns at our own company. I have an audit firm at Westlands. When I look at these guys, and some of them have a BCom, they have in this case here CPA. At times when you look at the kind of work they're doing, no. First of all, their Excel skills are very, very low. I don't know how this happened, because during our times, we were being mentored very well. I finished in this case here my CPA and the ACCA being a superstar in terms of Excel. I knew how to pivot tables long time ago, how to do the VLOOKUPs. Nowadays, you give a student, in this case here, big data, tell this student here to just pick up one thing, they're not able to use any lookup function. All right. And that is why some of us were very, very lucky. Before I came to RCM full-time, I was working for a good company, really good. It's an American company. Yeah, it's called Arrow. Yeah, American and Swedish. Yeah, Swedes have shares here. American equity, some equity firm as a very big, very big company. Yeah, they have made software, like the software which breweries uses to consolidate their financial statements, etc. Yeah, Equity Bank, KCB Bank, they were using this software. Even now, they use this software. So how was I able to get to this software industry? Because of Excel. Because of Excel. So we have introduced this Excel course in December. So ensure that you join this Excel class, all of you, immediately after your paper like this. If you're finishing your papers on Friday, that very Saturday, imagine we are starting our Excel course. Yeah, and it's going to be given to you at a very subsidized price. I think it is 2,500. There is a discount for our students like that. Take advantage of those things. And then on top of that, try to understand the IFRSs. Don't study this thing for the sake of just passing exams. Like financial reporting is a paper you should be very good at, advanced financial reporting like that, and then ensure you're good in automation. You can run these numbers in Tally. Get, in this case here, data of organizations from different industries. Get their data, enter this data into QuickBooks. From entering the data into QuickBooks, get a TB. Once you get a TB, then are you able to do even the final reports alone? If QuickBooks, for example, was to just give you a TB, are you able to use, in this case here, for example, some ifs function in Excel to come up with the financial reports, income statement, statement of cash flows, a statement of a financial position, etc., even notes to the accounts. All right. Once then you start running like that, you'll become a superstar. So invest in yourself. Otherwise, thank you very much. And if you want more information about those courses, I can see so many guys who are saying, Mwalimu, after exams, I would want to sleep the whole month. No problem. Then get to simply advertise yourself, that you're able to file returns. Start telling people outside here that I can do this iTax thing. Also study with us. We have this iTax course at a very subsidized price. Yeah, so please hit us, our number. Otherwise, it has been a pleasure hosting you. Thank you so much, and bye-bye. I can see a hand here. I don't know whose hand is this. Whose hand is this? I don't know. You want me to open the mic? But in Lincoln, we have always tried doing opening of these mics. It's crazy. I would rather somebody puts up their mic, their hands up, and then I open individual mics. Yeah, it's both online and physical. If you want online, most of our students attend online classes. Physical is like 10 students. Yeah, like 10 students, like that. Yeah, and I will be the one teaching the Excel. Kuombea wanafunzi bado ni mapema, bado ni mapema. Hatujafika hapo bado. Sitaomba Sunday evening. Nikiomba saizi, I'm so sure I'll never appear in your class again. I don't want to pray now. I would rather pray on Sunday evening. But of course, as we study, also God should be gracious enough to open our eyes. That is the request you're making to our dear Lord. He should be gracious enough to open our eyes in a way that we shall be reading things that may come in exams. It will be very, very bad to read so many things and then none of it comes in an exam. That is ungodly. That's ungodly. We shall overcome. We shall overcome. All right. Yeah, we also have the general IAI. What do I do? Give us topics that we should. No, not at my level. You know, I have a big. I mean, I'm really respected outside here. If I start, ladies and gentlemen, telling you like this will come, this will come. Even if I was an examiner, I don't think it's ethical. I would rather give you my very best in terms of what you're teaching, and then I leave it like that. Is not the very best way of growing a college. No. We want a sustainable model where our students, in this case, like now, the ones who will be graduating next Friday, they're happy. They never got leakages. No, I want you to learn these things like that. You pass because you really deserve it. And again, of course, if you have been in our classes, you'll be able to see these things in an exam. We have taught you before. I taught you FR last semester. Yeah, you passed. We never gave you any leakage. You passed. So don't look for leakages a lot. No. No, 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 no. Thank you so much. Okay. I know Lincoln very well. I know Lincoln very well. He's a young man at Jomo Kenyatta University. Yeah, I know him very well. Thank you so much. Make the shorter courses cheaper. We shall 𝑤𝑖𝐻 triple A. Please, please, thank you so much. Thank you so much. Tomorrow we shall meet. I'll tell you the time on WhatsApp. I'll tell you the time on WhatsApp. Good night. Na mlale masaa mengi na mkiweza pia mnakunywa maji mingi. You shall be very, very hydrated throughout. So that you can do like minimum 6 to 7 hours of sleep. But of course, after some time, wake up, study, take breaks. Again, you should not study like it's an exam from hell. No, no. Bye. Haiwezi wakausha kama stima, hapana.